We are going to get started, and so it is my great pleasure to introduce our next two speakers. I have with me on stage Andrei Saygo and Jhilakshi Sharma. Please give them a warm welcome. Go ahead, guys.
So hey, everyone. Thanks for coming to our presentation. So first, a quick show of hands, just so we know how to tailor this presentation. Who here is familiar with Yara? All right, that's quite a few hands. All right, so let's see how we can find vulnerabilities through Yara. So just a quick disclaimer. We do assume that you are somewhat familiar with Yara, and some of the vulnerabilities we'll be presenting here. But please feel free to come to us with questions after the session. We will also have a speaker Q&A at the end of the day, so we can address them there too. So a few words about us. I'm Jhilakshi, and this is Andrei. And we work for the Microsoft Security Response Center online services team. Most of our time is spent looking at vulnerabilities that are reported to us by internal and external researchers. And we also hunt for 0 days as a result of looking at variants of these vulnerabilities that are reported to us. So why Yara? That's a good question. We know that there are quite a few good tools out there that perform similar tasks and are very good at static analysis. Well, the answer is Yara is easy to use. It has a good community. A lot of people here would be familiar with it. And it doesn't take ages to write up a detection. And like any other tool that's out there, Yara is as good as the rules you write for it, and as good as the rules that reflect the vulnerabilities. So if your rule is defining the vulnerability accurately, that's how you can use this tool effectively. So speaking of vulnerabilities, let's see how we can find them in our ADO, in our source code. So how do we find vulnerabilities in MS source code? We're going to do a quick walkthrough of some of the vulnerabilities we've worked on and the signatures that we created for them. So the first set of signatures that we worked on here correspond to the Newtonsoft JSON deserialization vulnerability. And the rule at the bottom corresponds to the loose regular expressions vulnerability. And if you look at the first slide, the first image up there, that defines whenever the JSON convert function has been used. That's a Newtonsoft method, and it basically tries and detects whenever JSON convert has been used in code. And we have to look for use cases when that has been used in combination with insecure type name handling. And so that's the image to the right. And type name handling is basically a property that defines how a serializer handles the type name reading and writing. And so over here, you can see that the property is set to objects and all. And that's the insecure property setting to have in code. Because whenever you see this, what the Newtonsoft JSON convert function will try to do is it'll try and guess the type of the object we have in data, and it will try and deserialize it. So the safe values to have in code for this would be either not have it in code, which is the default value to have, or have it set to none. And so these are the insecure properties that we have to look for in combination with the first function we see there, that is JSON convert. And later during the presentation, we will explain how it can be further more vulnerable whenever it's used in combination with the public object declaration rule we have there. And yeah, we will also explain the loose regular expressions rule with the help of an example. All right, so here we see how Yara is run real quick. And we are trying to record the scan results in the demo.log file. And you can see that it didn't really take very long. And that's one of the reasons that we do use Yara, because it's very easy to use and quick. And we found multiple results for the rules that we'd written, but we chose to only display these 2 files. So the first file will demonstrate the deserialization vulnerability that we just explained in the previous slides. And so as you can see, between line 1 to 5, there are type name handling properties set there. And what the code is basically trying to depict that is, it doesn't matter whether you have type name handling.all or objects, it will have a similar insecure deserialization effect. And so now we look at the 2 examples we have here. So on the left side image, both these examples try to deserialize that generic object to our custom type account. And this is not going to be successful because before the deserialization happens, the JSON.NET library will try and convert this into it will check for the type, and it will convert the malicious payload string and execute it. And therefore, before the deserialization is finished, the malicious payload string would already be executed. And the reason this is happening is because whenever generic variables or objects such as object and var has been used, such as on line 11 and on line 20, we see that the constructor that's called first, which usually contains the malicious executable, the malicious payload string gets fed into the constructor. So even if the object raises some kind of exception, it's already too late by that time. And the JSON convert function already converts the generic objects into an executable, and that's when it executes. So those are the 2 examples on the left side. On the right side, what we see here is we have our custom type account, and this example will also be vulnerable because we see that the class account contains public generic objects as well, as you can see on line 37. So whenever a custom class like account contains a generic object like details, or it contains another class like XYZ, which contains public generic objects in turn, as you can see on line 43, that will have the similar effect as the first 2 examples we see on the left side image. And so all these 3 examples will be vulnerable here, just because public generic objects have been used. Like we said, we would explain the 3 signatures in the beginning when we were looking at the signatures. And they're all vulnerable because an insecure tightening property has been set in code, as you can see between the first class that's been defined here. All right, now that we're done with the Newton-Soft JSON deserialization vulnerability, we come to the next vulnerability we try to write a signature for, and that is loose regular expressions. And this can be particularly interesting because it could lead to a varying number of vulnerabilities. It just depends on where it's been implemented. So for example, here we have a file called webhook.cs, and we can see that on line 114 and 15, we're doing some kind of whitelisting, and it's a hostname whitelist. And the way it's been defined is you see $* in the beginning of both those lines. So the whitelist will try and filter the user input according to host names. So it will try, what it's trying to do is whitelist anything with account linking.amazon.com for the host names it wants. But it's not going to work because the whitelisting is actually done in terms of URIs. So if an attacker provides a payload in terms of, like, if they provide a malicious prefix in combination with account linking.amazon.com, they will be successful in providing that payload, and the user will get redirected to their control server, which would equate to anything that follows that format. And so this reflects an open redirect vulnerability. But if the same thing has been done in an internal server, an internal code where server A is trying to forward a request to server B, then this can the same code can lead to an SSRF. And if it's been used in an OAuth implementation in terms of redirect URI, you have various dangling domains that are defined in this format. Like, it can also lead to an OAuth misconfiguration where you can get auth codes on an authorization server that's been provided by the attacker. So yeah, it just depends on where this has been implemented. In this particular case, it's vulnerable because webhooks have been used in certain Microsoft services such as function apps and logic apps. And so if an attacker is successful in getting the user to open redirect to their server, they can get access to tokens with very permissive claims because these apps are used to get requests from Microsoft Graph to whatever custom endpoints we define at the time of configuration. So that's how we get and see loose regular expressions being vulnerable in code. So the next use case that we chose to write signatures for is something we found through our cases. And here you can see that there are admin credentials for a VM being set with the data type string. And we'll see why this could be a vulnerability. So this is the vulnerability we're dealing with. Whenever we have insecure data types in Azure Resource Manager templates, that is something we have to be looking out for. So for example, we have this template here. And if the credentials for this template, like they've been demonstrated here, if they've been set with the type string instead of secure string, then any user with read access will be able to view these credentials in code. And that could effectively lead to an elevation of privilege vulnerability. And it just depends on the kind of privilege that the user that has access to these credentials has. So now we try and see how we can make signatures for these. We know that Azure Resource Manager templates, they support data types that store information that is used during deployments. And they are basically JSON files that contain this infrastructure as code for the Azure Resource Manager solution. So we basically have to make a signature that can help detect a secret or password or any type of credentials or tokens in these JSON files. So as you can see, that we're trying to do that here. And whenever we detect that in combination with an insecure data type such as string, that this rule should be able to detect all those use cases. And we actually found more vulnerabilities in our code using this signature. All right, so this vulnerability is of particular interest. We've tried to write signatures for this too. And the reason why it's interesting is because CI/CD pipelines are emerging more these days. We are trying to look into, there's less research in this area, and we're trying to look into it and see how we can detect it before others do. And so I'll try and define pull request target a little more. So it's an event in a workflow that is used in combination with GitHub Actions. And whenever this has been used, then as you can see in the beginning of this workflow, on pull request target has been used here. Then you get read and write access to the target repository, which would basically be the base repository you fork your repository from. If you ever want to use open source code that's out there that's been published by Microsoft or any other company, you usually fork that repository so that you can work with it on your own. And so what this does is it gives read and write access onto the original repository, and you also get access to secrets that way of the original repository. And so in order to detect this in code, obviously we'll have to try and have that as part of our signature. And we see what it has to be used in combination with. And here you can see that the checkout action has been used. And under uses, actions.checkout has been used. And the primary mistake that people make while defining a workflow is using on pull request target in combination with actions.checkout, action/checkout. And what they're doing here is with the ref and the repository argument, they're pulling the pull request head into the workflow. So the head of a pull request is basically the latest merge commit you have in a fork repository. And if you pull that into the workflow, then that particular pull request can have malicious code, and it gives them execution and read and write access onto the original repository. So you see that happening here under with ref and repository. And so now we found the source of this vulnerability. Now we have to look at the workflow and see where the sink lies. And I think a lot of you must have already noticed that we have run npm install. If you're familiar with dependency confusion vulnerabilities, that's one way we can have a sink here. So what you can generally do is, in your fork repository, you can go and try and see the package.json file corresponding to the npm package, and try and modify the script section. And you can try and include a script which would be malicious. And for example, you include some code to get a token on your collaborator or whatever server you have. And you inject that in the package.json file. So whenever the installation is being done after the workflow is run, that automatically happens before the installation if you've used it as a pre-installed script. And what happens is once malicious code has been injected into your workflow, every step of the job after that, like for example, here it would be some command after npm install, it also gets compromised. So you can use some command to compromise some secret, and you will get access to environmental variables that way. And that will help you compromise the base repository that you forked your own repository from. So in the next slide, we're actually going to see how this vulnerability works. So here we have two accounts. One's the attacker account, one's the victim account. And we check the workflow in the victim account that we're trying to fork the repository from and see if it's vulnerable, if it has any untrusted pull request checkouts. So that's one of the workflows that was defined there. And we see that pull request target is being used here in combination with actions checkout, pulling out the pull request head. And we now check for possible sinks in there. And I think we have multiple sinks here. There's an installation. There's also npm run build, which is what we try to compromise here. And so now we fork this repository, and we are going to make changes in the forked repository. So once we fork the repository, we try and find the files that correspond to the steps in the job. And we will find package.json here. And we're trying, in this particular example, we're trying to bypass the workflow setting, which is require approval from first-time collaborators. So we will make two commits here. And so the commit from the second commit should be the one that executes. All right, so we see that we've added the malicious script onto the package.json file, and we don't really have any hits on our collaborator yet. But once this commit has a pull request created for it, we will then try and see. There will be two pull requests because we've made two merge commits, and we'll try and run the workflow each time. And so once that's done, we will look at the workflow running the second time. And so we see that the workflow is being run here. And the GitHub token that we received has write permissions over the base repository. And so now we try and move down to the next steps that was corresponding to the workflow. And we see that run npm install is being run here. And after that, when we get to npm run build, we see that our code is being executed. and there's a request being sent to our collaborator. And we got hits on our collaborator because of the malicious code that was injected into our build. And we get all sorts of environmental variable information. And if we scroll down here, we will also see that we got the GitHub token for the base repository. And this could lead to the compromising of the base repository, and we can perform remote code execution once we have this token. So now that we know how that works, we will try and make a signature for it. And so we saw the source of the bug in the previous slide that we presented. And as we can see, there were two lines that were of importance to us. One was the pull request target that has to be present in code, because that's what gives us read and write access over the base repository. And the second string tries to detect whenever the GitHub action checkout is being used. And so whenever these are being used in combination with each other, that's when we have a vulnerability. And then once we find workflows through this Yara signature, we will try and look for sinks to exploit those corresponding workflows. So this is how you try and find vulnerabilities using Yara in your source code whenever you have access to it. Now, Andrei will come and explain how you can find vulnerabilities when you don't have access to source code and want to use the Yara signatures on your own.
Thank you very much, Jhilakshi. Hopefully it was interesting. And now we're going to look at a different facet of things. For example, we have access to a lot of cases, and so they're very diverse. But what happens if, for example, you don't have access to a stream of, let's say, a feed of cases like we do? Well, don't despair. Maybe you've heard of ExploitDB, or maybe you've heard of Packet Storm Security, and I can probably say another 10 sites which have a similar stream of information, like about vulnerabilities, exploits, and so on. Actually, just a quick show of hands. Anyone that hasn't heard of ExploitDB? Only one person, wow. Oh, two, sorry, okay, 2 persons, okay. So, just a quick information about this. ExploitDB has a really nice interface, so you can search for the type of exploit. You can see, okay, I want remote exploits, I want local exploits. I'm looking at, okay, I want C#, PHP, you name it. You can pick, it's very easy to pick what you want to work on or what you want to study or research. And just because I like PHP, please don't judge me. And of course, WordPress, again, no judging, please. I like to study those things and then research and see what's out there. But the other thing is, this kind of research, just like you've seen with the MSRC cases, they give us a lot of information about vulnerabilities and most importantly, how we can write detections. But in order to get a detection, first we have to find the actual code that is vulnerable. So I'm not going to say ExploitDB because there are a lot of websites. So they usually provide a script, an exploit script. Let's say a Python in this case. And they will have some information about how to exploit a vulnerability, how to send a payload, and so on. And in this case, what attracted our attention is the thing that is highlighted there, the v1/order path. So this is something that we're going to have to search through the source code and see if we can find it. Now, why like WordPress, among other things, is that the plugins, the code for the plugins, it's actually available. So you can just go and download a zip file with a source code, extract, and then go through it and see if you can find what you're interested in. Now, in case you're not familiar with the program with the blue background, I use it a lot. It's called FAR. Anyone here actually heard of Norton Commander? It's like thousands of years old. Okay, perfect. So it's very similar to that one, but has like a lot more functionality. And I think I'll stop there. Otherwise, we can use the entire time and talk about this one. Yeah, one of the things that you can easily search for files for let's say a certain string in files and so on. So what we found, we went for that v1/order, and we found that it has a callback function. And then this callback function gets us here in this new one. Now, you might expect to, because this one is a SQL injection vulnerability, you might expect to see some SQL code. Well, where is it? Well, I was asking myself the same thing. Where is that code? Well, another thing that attracted my attention and then I highlighted there was the fact that there is the sanitize text field function. So the developer actually tried to make sure there is no vulnerability. Yeah, they sanitized the input. Well, there is a small issue. You have to read the fine print. Sometimes you have to read the documentation. Now, the thing is that this sanitized text field doesn't necessarily do what you might expect, like doesn't sanitize against everything. In this case, it's looking only at let's say, trying to remove the HTML tags, but doesn't do anything, let's say, a quote or a double quote. So can't actually prevent against SQL injection. Now, the second part is, OK, let's say we follow the code, and at the end, we just have a return with a new class, the member order class. And that's it. So then we have to go again in a new hunt and try to see if we can find that class and see what's going on there. Again, you're probably familiar from the previous video. We're using var, we search for that specific string, we locate the class, and because there was no method involved, we're actually gonna go and try to find the constructor. And this is the function constructor. As you can see, first it checks to see if it's numeric, like the code, yeah, if it's numeric, then it will handle it one way, but if it's not numeric, it will try to handle it a different way. Of course, there is no sanitization here because the code is supposed to have been sanitized already, if you remember from the previous slide. And once you search through the function that is called, we actually see the SQL injection, and I think it's obvious. Anyone here doesn't see the SQL injection? If not, I can explain it. OK, no hands up. That's perfect. OK, now we pretty much have everything that we need in order to create our Yara signature. OK, I want your opinion. What do you think about this signature? And I've seen many hands up when we asked about if you're using Yara. So it doesn't matter. There is no good or bad answer here. So anyone can tell me if this signature is good, if they can improve it. Anything? No one? OK. OK. So what you see here, we actually went specifically, and please feel free to interrupt me once you have an idea or you want to say something. So here we actually went specifically for the select function. And here you have like two, let's say, ways of thinking, methods of thought. You can use the signatures to detect a specific vulnerability, or you can make them a bit more generic and say, OK, besides the select, I want to detect like more generic SQL injection, like whenever I create a table, whenever I update a field, or things like that. So it really depends on what you're trying to do. And you're going to see this one later in the talk, and we're going to talk a bit about at the end. It's up to you if you want to hunt for new things, or if you want to, let's say, provide this to the developer and say, each time there is a hit like this, they need to fix the code because this is a valid vulnerability. The other thing is that, OK, I'm willing to accept some false positives because maybe 1 in 10, 1 in 20, maybe that is a vulnerability that would otherwise I may have missed. All right, now that we handled the PHP part, let's go to something which I actually find more interesting. Well, actually, let's say at the same level, because I already said I like WordPress. So what about firmware? Anyone here analyze firmware? Excellent. OK. And I may ask you something. I'll have to remember the people that had their hands up. So you have seen Yara handling a lot of text files, right? Well, another thing that Yara is known for, and maybe a lot of you have used it in the past for malware analysis. Of course, in malware analysis, you have strings, you have JavaScript, you have macros, and so on, but you also have binaries, you have executables, which don't necessarily have strings, depending on how they're packed and so on. Well, kind of the same with firmware in the beginning, and yeah, we'll see how that one goes. But first, once we're going to follow the exact same process like we've done the previous time. So we're going to look at the exploit script, and then we're going to look at, OK, what are the interesting things in this exploit script that we can use in order to search for what we need. And same like with the previous one, we have the vulnerable file, which in this case it's upgrade.cgi, and then the second one, it's the firmware underscore URL, which is supposed to have the payload. So let's see how we can get that. Well, if you spend time analyzing firmware, and please feel free to correct me if I'm wrong, but it's really difficult to get to the source code. Am I right or not? Do I see some head nods? Yes, I do. Well, the thing is that if you ever analyze malware, think of it about firmware like they're obfuscated kind of in a way, or tightly packed. And there are multiple reasons for it. I think the developers are thinking, OK, we don't have much space, so we want to keep everything at the minimum. I think it's just because they want to make our life much harder. But that's maybe just me. Now, if there is one thing to remember from this talk is that there are tools out there that can, let's say, help you extract files from firmware. There aren't many, but there are some. And for example, Beanwalk, it's free and very good in my opinion. I've used it quite a lot. And one thing to remember from this, if you ever use Beanwalk, is the -em parameter. This is the only thing that you need when you deal with a firmware to try to extract the files. Basically, E tells you to extract, and and the M parameter goes and says, oh, you can do this automatically. So whenever you extract something, it will parse that something, and then it will extract again. So you don't have to spend like I don't know, do the same command like thousands of times to extract all the files from a firmware. All right, now that we have everything extracted, and you can see here, it has a bunch of stuff. So you're going to have like layers upon layers of obfuscation, if you want, until you can actually reach to the code that you need. Now, the thing is with a lot of let's say, a lot of firmware, you will have a Linux device and then a PHP code. And then, you're going to have those devices run some PHP and then web interface and so on. So we expect something like this in this case. So what, if you remember from the previous slide, we're searching right now for the firmware underscore URL and upgrade.cgi file. And we found it. So now everything should be much, much easier. We just see the PHP code. Everything should be easy and straightforward to write a signature. Well, there is a problem. Actually, this is not PHP code. This is an executable. So now, what do you think is going to happen with Yara? Would we be able to create a signature or not? Come on, anyone? A vote of confidence, please? No? No? OK, well, let's find out. I know. I'm very curious myself. So let's see what's going to happen. Well, we had to use some tools because, it's not easy to go through the executable part and see what's going on. So what we did was we disassembled the file, and based on the data that we knew, we searched for example for the firmware underscore URL. We're able to find, let's say, this pseudocode and go and see what's going on. I mean, I won't bother you with all the details. You can see the slide. But the main thing here is that the input that we're going to get from the web parameter, which is fully controlled by the user, just so you remember, it's actually sent to the wget command without any kind of sanitization at all. And of course, you may ask, what's wrong with that? Well, I'm glad that you asked. Let me tell you. So what happens if we send something like this? We like command pipe, and then we set, let's say, a reverse shell. Well, what happens is that we have a full remote code execution on the device. So you actually control that device from the comfort of your chair, or I mean, your beanbag, or whatever you prefer. So yeah, in this case, you can list files. Of course, you're depending on how what the user writes that are on the system, but at least you have another bot in your entire botnet, or if you crypto mine, it's up to you. I'm not gonna judge. Okay, so now we pretty much have everything that we need in order to create our Yara signature. And here I'm gonna need your help. So please help me. So how would you create the Yara signature here? You have like the strings, and then imagine on your right-hand side, what you see there as a pseudocode, it's actually binary code. So how would you create a Yara signature? And I need your help. Let's see, anyone here wants to help? Please, come on, there are so many people that are using Yara. No one? Come on, only one. Okay, I thought I saw, okay, I'm gonna explain a bit here how you can do things. So you have, again, like with the previous SQL example with select, you have here two possibilities. Either you use only binary code, so you'll detect the binary in the firmware, or you can use, let's say, a combination with binary code and some strings. Maybe, let's say, you want to make it a bit more resilient against, let's say, a new version of the firmware, and see, okay, I want to see, or maybe a different firmware, and you want to see the same vulnerability. Or, I mean, if you go only with the binary code, chances are it's going to be less, it's going to be more targeted. Now, the other option would be you can only go with strings. And I would advocate in this case of going only with strings for another reason. Because besides scanning the firmware in binary form, you can also scan the source code behind it. Now, of course, the planets have to align, like everything needs to be in one file and so on. Of course, you can create like multiple signatures and then combine them together. So yeah, there are a few things. But the idea is, if you use only strings, you will detect both the binary and the source code. So this is what we've done. We've created this really nice rule. In this case, first we started with wget. But then again, what happens if they use something else? What happens if they use another command? So again, it's up to you. It's up to let's say, if you want to do some hunting as well. Of course, you may end up just going into something that's totally not vulnerable. But it's, I mean, you can tweak the code and see what you get, and then, of course, spend some time researching, analyzing, and see what you can find. So in the end, we added this Yara signature, and we scanned our firmware. And we found our upgrade.cgi file. But we also found something else. Now, we did not spend any time analyzing it because we wanted to see if anyone here can help. And please send us an email once you finished analyzing this and tell us if it's actually a 0-day or not. If not, we're going to be happy to see it on ExploitDB or wherever you want to publish it. So thank you. And again, hopefully you enjoyed this talk. Maybe as much as we have enjoyed creating Yara signatures. And we also have a blog in case you have a question about where can I find those wonderful signatures that are very loose and don't have any kind of metadata and things like that. Well, if you search, we have a blog with like, I don't know, we have like, what, 20, 30 signatures there? Something like that. Again, they cover different languages, C#, PHP, and so on. But I wanted to finish and say, Yara is very useful, not only for binary, but for source code as well. And it's up to you what you wanna, how you wanna use it. I mean, yeah, of course, with great power comes great responsibility. You don't want to detect every file out there because it's going to take a while to go through them. But yeah, see how you can tweak things. Sometimes I have more of a hunt mindset. I'm OK with some false positives. Maybe you are not. It's up to you. But again, it's up to you how you wanna use it. Anything you wanna add, Jhilakshi?
No, just that the signatures are out there, and through them you can also learn about the vulnerabilities. So yeah, that's us.
Yeah, and most importantly, have fun when you're doing this. It's always fun to create Yara signatures and to detect stuff. So yeah, hopefully you enjoyed our talk. Thank you.